Okay, chapter 4.6 is now division of polynomials. So we've done adding, subtracting polynomials, and we've also done multiplying polynomials. So lastly, we'll do division of polynomials. So before we get into it, just recall that when we add two fractions, when they already have a common denominator, we just have to add their numerators and place them over that common denominator. So looking at it in the reverse direction from right to left, that's going to tell us how to divide a polynomial by a monomial. So starting with a plus b all divided by c, we're going to split it up. We're going to divide each term in the numerator, which is of the polynomial, by the monomial in the denominator. So let's do one with numbers here. So let's divide the following. So if we have 2 plus 5 over 3, so obviously that's 7 over 3. But we're not doing it that way. We're going to do it using that method above. We're going to split it up and give that denominator to each term in the numerator. So it's going to be 2/3 plus 5/3, which if we think about it in the reverse direction, we know that's true, because when we're adding the fractions, we combine the numerators and leave the denominator the same. Okay, so that one is with numbers. Let's do an actual problem. So 12x squared plus 6x over 6x. So we're going to give every term in the numerator its own denominator of 6x. So 12x squared divided by 6x plus 6x divided by 6x. So we split up the fraction, and then we have to simplify. So 12 divided by 6 is 2. X squared divided by x is just x. So we have to remember that that would be like subtracting the exponents. X squared divided by x, that's x to the 2 minus 1, x to the 1, which is just x. So 2x plus, and then 6x divided by 6x is just 1. So that whole thing simplifies to 2x plus 1. Next one, 5m to the 5th minus 10m cubed divided by 5m squared. So we're going to split it up. 5m to the 5th over 5m squared minus 10m cubed over 5m squared. 5 divided by 5 is 1. M to the 5th over m squared is m cubed. Minus 10 over 5 is 2. M cubed over m squared is just m. So m cubed minus m. Do a couple more. So 16 a to the 5th minus 12 a to the 4th plus 8a squared divided by 4a cubed. So 3 terms in the numerator. We're going to give all 3 of those terms its own denominator. So it'll look something like this. And then we're going to simplify them all separately. So 16 over 4 is 4. A to the 5th over a cubed is a squared, minus, we have 12 over 4, which is 3. A to the 4th over a cubed is a, and then plus 8 over 4 is 2. A squared over a cubed is going to give us an a in the denominator. So that would give us a to the negative 1 in the numerator, which ends up being 1 over a to the positive 1, so a in the denominator. Okay, so one more here. So we have negative 7x cubed plus 12x to the 4th minus 4x, all divided by negative 4x. So giving each one of these in the numerator its own denominator, we end up getting this. And when we simplify it, negative 7 over negative 4, the negatives cancel. And then we have x cubed over x, which leaves us with x squared. So 7x squared over 4. I'm going to write this as 7/4 x squared. Okay, so 7/4 times x squared. And then for the next one, 12 over negative 4, we know it's going to be minus 3. 12 over 4 is 3, but it was negative. X to the 4th over x leaves us with x cubed. For the last one, we have negative and a negative, so it's going to end up being positive. 4x over 4x is just 1, so positive 1. Okay, so that's the answer for that one. Okay, so in a second we're about to divide by polynomials that are not monomials in the denominator. So before we do that, let's take a look at what we call the division algorithm. So when we're dividing two numbers, it's the numerator divided by the denominator. Another word for the numerator is the dividend. And another word for the denominator would be the divisor, so the divisor. When we divide them, we end up getting the quotient plus the remainder divided by the divisor. So this whole thing is the division algorithm. So we kind of already knew this. So let's kind of explain why we knew this. Let's divide 37 over 5. Let's convert that to a mixed number. Oops. So that's going to be 37 divided by 5. 5 goes into 37 7 times. Multiply, subtract, we get 2. So this is our quotient. The 7 is the quotient. The 37 is the dividend, because that was the original numerator. This 2 is the remainder. The 5 is the divisor, because that was the original denominator. So writing this in the form of this division algorithm, it's going to be 37 over 5 equals the quotient, which is 7, plus the remainder over the divisor. So 37 over 5 equals 7 plus 2/5. So we already knew this because 7 plus 2/5 is a mixed number. We would just write it as 7 and 2/5. So technically a mixed number is using that division algorithm. So hopefully that makes sense. Now it's going to get a little bit harder though, because we're going to be doing with polynomials instead of numbers. So the way we're going to do this when we're dividing polynomials, we're going to start by dividing the highest degree in the numerator and the denominator, so dividend and divisor. And then we're going to proceed like we would when we're doing with numbers. We're going to take that value that we just got, multiply it by the divisor, and then subtract it from the dividend, and repeat. We're going to keep on doing this until the degree of the remainder is less than the degree of the divisor. And then our answer is going to be, our dividend and our divisor, when we're actually dividing them, we have to make sure they're in standard form, so descending order for the exponents. And if a term is missing, in the dividend or divisor technically also, we should write in a 0 as the coefficient and include that term. That's important. I'll kind of mention it when we get there. It's important because everything will line up the way that we want it to. And then once we get an answer, we're going to write the answer in the form of the division algorithm. So let's divide these so we can get an idea. So we want to do x squared plus 10x plus 21 over x plus 3. So I'm going to set this up using the long division method. Okay, so x squared plus 10x plus 21 divided by x plus 3. So where we start is we take the largest degree in both of them. So the highest degree in the dividend is x squared. We're going to divide that by the highest degree in the divisor, which is x. X squared over x is x. So that's how we know that's going to be the first term in our quotient. So we put the x up there. I put it directly above the other x in the dividend, so for nice in order. Then what we're going to do is we're going to multiply the x by the x plus 3. We get x squared plus 3x, and we have to remember that we are subtracting that. So x squared minus x squared, those cancel, which they always will. 10x minus 3x is 7x. We bring down the 21 and we do it again. So we start again and we say how many, we go to the highest degree in the new dividend, which is 7x. We divide that by the highest degree in the divisor, which is x. 7x divided by x is just 7. So it's going to be plus 7 for the quotient. We're going to multiply 7 times x plus 3. We get 7x plus 21. We have to remember that we're subtracting that, and we actually get a remainder of 0. 7x minus 7x cancels, and actually the 21 ends up canceling also. Okay, so setting this up using the division algorithm, that's x squared plus 10x plus 21 divided by x plus 3. So that was just the original problem. That's going to equal the quotient plus the remainder over the divisor. So it's going to equal x plus 7 plus the remainder over the divisor. So obviously this is kind of silly to write it this way because the 0 in the numerator makes that whole thing 0. So I'm just going to rewrite it just like that, and that's our final answer. So that whole thing ends up equaling just x plus 7. Let's do a couple more examples. 4 minus 5x minus x squared plus 6x cubed divided by 3x minus 2. So the dividend here we have to make sure is in standard form. It's 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2. So now we're going to divide the largest terms here, the highest degrees. 6x cubed divided by 3x gives us 2x squared. And that 2x squared is going to go in the quotient. So then we're going to multiply 2x squared by 3x minus 2. We get 6x cubed minus 4x squared. We have to subtract it. The cube terms are going to cancel. Then we get negative x squared minus negative 4x squared. That's negative x squared plus 4x squared, which is 3x squared. Bring down these other terms, and then we just repeat that process. So on the side, we have to divide those highest terms. 3x squared divided by 3x, that gives us just x. So it's plus x in the quotient. Then we have to multiply x times 3x minus 2. That's 3x squared minus 2x. And we're subtracting it. The x squared terms cancel. Negative 5x minus negative 2x. Negative 5 plus 2, that gives us negative 3x. Bring down the plus 4. So then, once again, one more time, we divide the highest terms, negative 3x divided by 3x. That gives us negative 1. So that's our last term in the quotient. Multiply by negative 1, we end up getting negative 3x plus 2 when we multiply it by the divisor. We subtract, 4 minus 2 is 2, and that's our remainder. So writing this in the form of the division algorithm, it's going to be what we started with. The 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2, so that's just repeating the problem again, equals the quotient, which is 2x squared plus x minus 1, plus the remainder over the original divisor. So there is our final answer in the form of the division algorithm. Okay, so for this next one, 6x to the fourth plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. So writing this out, we notice that we're missing a squared term in the dividend, so I'm going to write plus 0x squared. And then we'll see when I do this, it's all going to line up a lot nicer. Okay, so we're going to divide it. So same thing, it's going to be dividing those highest terms, those leading terms. So 6x to the fourth divided by 3x squared gives us 2x squared. So that's the first term in the quotient. We're going to multiply that by the divisor. We get 6x to the fourth minus 4x cubed. And we know that we're subtracting that. Those cancel. We get 5 minus negative 4, so 5 plus 4, so 9x cubed. Then we're going to bring down everything else. So plus 0x squared plus 3x minus 5. Divide those leading terms, 9x cubed divided by 3x squared. We get 3x. So that's our next term in the quotient. So 3x times the divisor, we get 9x cubed minus 6x squared. We're subtracting it. The cube terms cancel. So now you can see why we have that x squared term in there with the 0x squared, because it lines up with the other one that we just put in there. So it's 0 minus negative 6. 0 plus 6 is 6x squared. Bring down those other two. And it looks like this is going to be the last time we could do it. 6x squared divided by 3x squared equals 2. So that's going to be plus 2. Multiply 2 by the divisor. It's going to be 6x squared minus 4x. The x squared terms cancel. 3 minus negative 4, 3 plus 4, 7x. Lastly, bring down that minus 5. That's degree 1 because it's x to the first power. Our divisor is degree 2 because it was x squared, so that's our remainder. So writing this in the form of the division algorithm, just going to repeat the problem. So it was 6x to the fourth plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. And that's going to equal the quotient, which is 2x squared plus 3x plus 2, plus the remainder, 7x minus 5, divided by the original divisor. Okay, so that would be our answer for this one. Okay, so for this next one, dividing these two, what I'm going to do is pause the video and then I'm going to fill it in and kind of skip to the answer if you wanted to try it. And then I'll do one more for the last one. And I'll go through and just show you a quick little tip for that one. Okay, so when we divided this is what we end up getting. We get, written in the division algorithm, those two polynomials divided equals 2x plus 3 plus negative 8x plus 10 divided by x squared plus 2x minus 1. So for this last one here, let's do the setup. So I'm going to have the setup as 4x cubed minus 2x squared. It's missing the x term, so I'm going to throw in plus 0x, then minus 3. For the divisor, it's missing the x term, so I'm going to put in plus 0x for that missing term. And then now I'll pause the video and I'll go through and do it. Maybe you can try it on your own first. Okay, so this is what we get. We get a quotient of 2x minus 1. We get a remainder of 2x minus 4. And I set it up at the bottom using the division algorithm. So we knew to stop at 2x minus 4 because that is a degree 1 polynomial with the exponent being 1. The divisor is degree 2, so the remainder is less, the degree of the remainder is less than the divisor, so we were done. Okay, so that's it for section 4.6.